Hi guys, I hope everyone is doing well in their life. So today, without further ado, today I am going to discuss how to do any custom image dataset visualizations using graphs with the help of libraries in Python like Dash or Plotly and Networkx and Glob. So step 1, I will load image classification dataset using pattern matching. If you have no classes in image dataset, then no problem. You can modify the code for your liking. So I will first create a pattern where my dataset will be located. So inside natural images, I created a trick because this trick will pick up all of the classes of the subfolder. And suppose you have a car folder inside under natural images. It will pick up that car folder and all of the JPG images inside it. So if we have bike folder, it will pick up all of the JPG images inside it. So I have created a pattern. Then I got a list of image parts. And then I have created a data frame using random feature generation for image. You can create features. You can develop your own features like image, dullness, whiteness, average pixel width, dominant color. For the sake of the demo purpose, I have created features which are random, randomly generated features. But you can get features function and you can create a pandas data frame. Inside the pandas data frame, you have to create classes also, which will be this folder, this strict folder, which will be -2 after splitting with respect to this slash, double slash. So you will get the features classes also. So this is the step 2 in which I define a function named create underscore df that creates random features for images and give panda data frame as an output. Let me show you by running it. So you can see these features are generated as well as image location is stored as well as classes location is stored, classes names is stored. Then we can come to step 2 of the step 2. We can define a function named create underscore 3D underscore graph that takes the output of the first function and class name is an input. Then filters the data frame according to class name and give expired coordinate of the three-dimensional network X graph as an output. Let me show you by running it. You can pass threshold also 0 to between 0 to 0.999. So according to this threshold, you can keep only the correlation over a threshold and remove self correlation. It is loops of the a loop to a obviously, so we are not taking that correlation. We have to remove that. Uh, and then after let wait for some time for it to completely run. So as you can see, x coordinate, y coordinate, and z coordinate, an image URL is generated. And graph a 968 number of nodes and 46,000 4,60,293 edges. And 968 images are mapped to each other in the correlation matrix according to features which we have generated earlier. Okay, then what I have done further is I optimized the second function, create 3D graph such that the correlation matrix does not become a bottleneck step, and more than millions of pages can also be taken into account. How more than millions of pages can be taken into account? I can take computation of page sum over millions of edges into account. So instead of taking only uh, only a single weight value. I am taking the sum value of the weight by linking customer A to customer B, which is nothing but a renamed variable one, variable two. So after this, I am creating spring layout of the graph, which is nothing but forces linked to distance between nodes such that every vertices come into equilibrium, similar to balancing act of vectors in physics when they come into their final state. So by doing all this, I am getting the x coordinate, y coordinate, z coordinate, and image URL as an output. After that, I am creating my dataset, which is the main function. So for that, I am creating a main function that keeps the dataset to run as a final output. The role of the main function is that it takes the second function pandas data frame and shows image that is stored at a folder location in our laptop by using the concept of page encoding that encodes the actual image location to show only at the time of hovering and make it dynamically interactive. Let me run it and show you. So if we select class name, suppose motorbike, which is present in a dataset. And if we select threshold support 0, that means we do not want to remove any node, any edges below this threshold. So a dataset will be generated, which will take the 3D graph as an input, 3D data frame of the 3D graph, create underscore 3D graph function as an input, and filter by class wise and threshold, and generate the dataset. Let's wait for some time. As you can see, app created successfully for class equals to motorbike. You can go to this link which is dynamically generated, and you can see our bikes are, we can see different images of the bikes. We can zoom in and see the 3D visualization. So this is a graph. These points are coming from spring layout graph, which we are showing using the dasher. Let me show you for another class, say car, and threshold is this time let's say 0.9. As you can see, number of nodes is 968 and number of pages is 38,000, 38, 3,83,942. 968 is an individual image name which is interacting with any other image according to spring layout of the Networkx. You can see multiple cars are getting generated in the 3D visualization. So this way we can create an IP by NV widget that takes interact underscore manual instead of interact function. So why we choose advantage, why do we choose interact underscore manual over interact option? Simply because interact underscore manual give you time and space. It provides you with a button to interact properly while running the output. Unlike interact, which runs as soon as you change the slider value or the drop down value instead of waiting for you to fathom what is happening. So this is all about image dataset visualization using, or in other words, global explainability if you have image pictures. I hope you like this video, friends.